cardiac rhythm here. So normal sinus rhythm. All right. What is normal sinus rhythm? Sinus rhythm describes a cardiac impulse, again, that begins in the SA node and follows the natural path of progression down to the Purkinje fibers in the ventricles. The term normal is indicating that the impulse is occurring at a rate of 60 to 100 beats per minute. The reason for this is because this is the natural inherent rate of discharge at the SA node. Remember, we talked about that before. So, in order to understand deviations from normal, however, we first have to understand what normal is, or what it should be anyway. Now, in the next few images here, you're going to see rhythm cheat sheets as well as sample rhythm interpretations that we'll go ahead and work through together. All right. So first up here on the right, we've got a rhythm cheat sheet for normal sinus rhythm. Notice that the heart rate is in between 60 and 100 beats per minute, which is the normal inherent rate of discharge for the SA node. When we look at the regularity, it is regular. All of these P waves are marching out on time every time, as are the QRS complexes. Okay, so it's a regular rhythm. The P waves are all upright, and they also appear similar to one another. In addition, there's one P wave for each QRS complex. What this tells us is that for every beat that's initiated at the SA node, the ventricles picks this up in a one-to-one fashion. Okay, the PR interval is normal between 0.12 and 0.2 seconds, and it's constant. So this tells us that each beat is taking the same exact time to reach the ventricles. And finally, the QRS complex is less than or equal to 0.12 seconds, which is the normal range for the QRS. Remember, every time we see a narrow QRS, that tells us that the impulse is originating from above the ventricles. Okay, remember we talked about how the ventricular muscle is relatively thick and very slow to transmit and impulses and contract. When that impulse arrives, remember, on the fast track from the SA node or the atria above, we should always expect to see a nice tight QRS complex. Now, the only exception to this would be in the case of a bundle branch block, which we're not really going to get into in this video, but a little bit later on we might. So here on the next slide, we've got a sample rhythm interpretation that we'll follow along with using the concepts that we've discussed up to this point. Okay, so here we're working through our progression. This is the reason why we kind of laid that foundation earlier, right? Remember, RP and Q times 2, stat. That describes the process that we're going to work through for every rhythm that we break down together. So RP and Q times 2, rate, rhythm regularity, P waves, PR interval, QRS complex, QT interval, ST segment, and T waves. Okay, so let's work through this together pretty quickly here. So what's the rate? We're going to do this for both atrial and ventricular. The atrial rate is signified by our P waves. Okay, on our 6-second rhythm strip here, we have, well, before we get any further, let's describe the 6-second rhythm strip. We've talked about this before, but let's go ahead and revisit it. So luckily for us, we see our hash marks that are measuring out 3-second intervals here. The other way that we could verify this if we didn't have our hash marks here is to do what? Well, we could also count off 30 of our big boxes. Remember, each big box on the EKG paper or ECG paper is equal to 0.2 seconds. Okay? 0.2 seconds times 30 gives us 60 seconds. So 1, 2, 3, 4, 5, 6. We count all the way to 15, which is halfway, and another 15. So now that we know that we're dealing with a 6-second rhythm strip, calculating the rate becomes a little bit easier. So our atrial rate signified by the P waves, we have 1, 2, 3, 4, 5, 6, 7 P waves. Okay, so we have an atrial rate of 70. For the ventricular rate, this is going to be signified by the QRS complexes. I see 1, 2, 3, 4, 5, 6, 7 QRS complexes. The ventricular rate is 70. Now, for the regularity or irregularity of the rhythm itself, again, we're going to do this separately for both atrial and ventricular. All right. Is the atrial rhythm regular or is it irregular? All right. Do these P waves march out on time every time? If we had a set of calipers, we'd go ahead and measure the distance between these first 2 P waves and then transfer the calipers to the next 2 in line, and so on and so forth. But just looking at it, we can say that we have a regular atrial rate. So they're coming on time every time, those P waves are. Rhythm regularity for the ventricles is also regular. Notice how those R waves are marching out nice and routinely on time every time. Okay, P waves, they're present and they're all upright as they should be. Our PR interval, if we go ahead and measure the PR interval from the beginning of the P wave to the beginning of the QRS complex, I see 4 small boxes in there. Remember, each small box is equal to 0.04 seconds. So we have a PR interval of 0.16 seconds. That's within the normal range of 0.12 to 0.2, right? Next up is the QRS complex, okay? The QRS complex is a little bit greater than 1 small box, but it's a little bit less than 2 small boxes here. So the QRS complex is going to measure 0.06 seconds. Again, that's less than 0.12, which is the normal expected rate for the QRS complex. So the QRS complex width is said to be normal. It's narrow. The QT interval, remember, this is measured from the beginning of the QRS complex to the end of the T wave. The QT interval is measuring the time that it's taking for the ventricles to fully contract and depolarize and relax and repolarize at the end of the T wave. Remember, less than 0.44 as an absolute is what we use. Sometimes this may be less than 0.46 in women, or sometimes less than half of the R to R interval. But for this example strip here, we have 0.40 seconds, which is less than 0.44, so we're okay there. The ST segments, remember, relative to the isoelectric PR interval. These ST segments are nice and tight in line. The ST segment is measured typically from the J point, or 1 small box after the J point, to the beginning of the T wave, okay? All of our ST segments are nice and in line with our PR segment, so it's said to be okay. I don't see any elevation or depression. And finally, all of our T waves are nice and upright as they should be. So our final interpretation for this rhythm strip is a normal sinus rhythm.